This conference will now be recorded.
Is the Winter Hacker Festival, which is going to be a Bluetooth CTF, drone hacking, lockpick village. We're going to have some fire talks. I'm still waiting for volunteers to do some short talks about anything that you would like to do. So if you're in the South Florida area and want to come to an in-person event, this will be in person at the Renaissance Charter School at Cooper City. It'll be an all-day event from 10 a.m. to 4 p.m. roughly. So they're letting us into the room at 10. It'll probably take about 20 minutes to set up, and then we'll be doing our lockpick village again, Bluetooth CTF. Rod's doing his no quarter CTF as well. We're working out internet arrangements for that. And drone hacking. Rod's bringing over a drone. I'm gonna bring over some little toy drones. So if you have if you do bring any youngsters that want to come by that want to crash a micro drone, they're pretty fun. And I think bring over the 3D printer and see if I can find some small things that could be set to print out through the menu interface so people could get a handle for 3D printing. So it's a fun community event for our community as hackers, all right, and makers. If you guys want to come out, it's gonna be fun. It's free. Show up. I made roughly 50 little commemorative Winter Hacker Fest tokens to give out. So if you do come by, they're going to be limited. There's only 50 of them. So the first 50 people that do show up to get one. And I promise I won't make them anymore. So with for 2021, they actually have the MMXXI on the bottom for 2021 year. And you could have one, and we could probably do these as a collector's item for every year as we keep doing Winter Hacker Festival events. All right, this is our last actual meetup event today other than the Winter Hacker Fest for HackMiami for the rest of the year. Winter Hacker Fest is our actual final hurrah event. So, and then we have Christmas season, then we come back, I believe, January, around the mid-January timeframe to start our planning session for the next 6 months of events or meetings. So also I dropped in the link to our Discord channel. So if you want to jump onto our Discord and have fun chatting with everyone in the community, that's great to do as well. All right, and let me take it off and kick it off to Urban.
Thank you, Espeto. So again, welcome to HackMiami, the last meeting of the year. Besides the Winter Hacker Fest, Pacific Hackers will also be doing the same thing a week before you guys. So I guess we'll be the test run for HackMiami. The topic of today is cryptography, because crypto means cryptography, and I will die on that hill. My team has put together a brand new CTF platform, one that we are going to be deploying into everything that we do. So we're pretty excited to see this being used for the first time. So you guys are the first eyes. So feel free to give us some feedback and whatnot, because this is really exciting for us. We know from the students that we serve and the places that we go that cryptography tends to be one of those topics that everybody runs away from as soon as they hear, oh, you have to do math. So the team has been working on building a introductory CTF that shows you how you can do this without freaking out. And me personally, I am not a programmer. I don't like math, but this CTF has shown that, yes, you can do this and not freak out like many people do. So really happy to see this come together. The CTF is at this link, contest.basecyber.net. When you go there, right now we have a pretty simple page that has a username and password to it. There is a button that says sign up. Put your name in, put an email in, your username and password that you want to use. It doesn't have to be anything real. It's not going to verify your email. It's just information, so you could put any, you could be funny with it and put
Yeah, you
whatever
can
info you
use a
want.
dummy email.
Yeah.
We don't want your information.
Yeah, that'll work just fine. And then you log in, and bam, you're in. So you have a list of tools that we will be using throughout the CTF right in front of you. These buttons will take you to various tools and links that you'll use. On the right, there is a bar, and that bar will have the CTF questions. So everybody can either make a team if you'd like for yourself, or if you want to team up with somebody, go for it. It doesn't matter. So yeah, assign yourself a team and team name and make a password. Oh, that was for joining a team.
Oh, sorry.
To create a team, click on the gear icon.
Yeah. Yeah, so call your own team whatever you want and assign whatever password you want. For this event, remembering the team password isn't the worst of the worst, because it's just going to be this 2-hour event. And now once you make that team, you'll be able to see the various challenges and the scoreboard and everything you need to play this game. So I'm going to introduce the 3 presenters who will be guiding you on playing this game, and that's Jordan, Max, and Karen. And the rest of our team is also here: Jose, Abraham, Braulio, Tyler, and Tomas. So if you have any questions, please put them in the chat. We will be more than glad to help you out. With that, I'm going to hand it over to Karen, who will help, who will get started. And if you want to jump ahead, go for it. We have 7 categories. We're building out more questions as we go. Again, ask away, and any feedback is always welcomed. So Karen, it's all on you. Oh, let me make you presenter, or are you presenter?
I got it.
Not right now.
There you go.
I did want to mention that the front end for the hints feature is not available yet on our new platform. So if you see hint available in the description or in the question text, that means there is a hint available. And if you want the hint information, please just message in the chat that you want it, and we'll get back to you with that hint information. So with that, the first question in the introduction section is just about our flag format. Should be pretty self-explanatory, so I'm not going to walk through that with you guys. The second question should be pincher. Sorry, there's some order differences from how we first set this up. And this second question mostly is asking about the purpose of cryptography, or one of the core purposes of cryptography, and its place within security. The answer to this is based on the CIA triad. and you can get to the answer by Googling for purposes of cryptography.
Karen, can you show the question? Because all we're seeing is Google right now.
Yeah, I can sign up on the I can log in on contest.baycyber and show the questions.
Yes,
Sure.
please.
Also, one thing to keep in mind, right now with the front end functionality, to see scoreboard updates, you need to refresh the browser.
All little things that we'll be fixing as we go.
Okay, can everybody see the challenges now?
Yes.
Yep.
Okay, that's great. So hopefully everybody's passed the first question. Do you want me to read the questions? Would that be helpful?
Looking at
No,
chat.
with CTF, I think people have questions. You could message Karen privately or any of the other people in there, and
Yeah,
let
you can just
uh,
drop a line in the chat and we'll get to you.
yeah. Let's see how it goes.
Okay,
It's
great.
fun.
The next question, names for 200. Is a really about terminology in cryptography. So what is an encrypted message? What is encryption? What is decryption? What is plain text? If you Google the phrase term for encrypted message text, you will get the answer to this question.
Yeah, one thing that I found that's interesting with cryptography is it's sort of its own vast field. And so having a foundational understanding of some of the terminology that's used, I think can help make things less confusing. Because even when I first started out, I was like getting confused if encryption, what the difference was between encryption and encoding. And, it can be a little circular with kind of moving from one bit of text, you're doing something to it to alter it to become this ciphertext, and you're doing something again to have it, come back to this plain text, sort of these inverse relationships. So we definitely wanted to have something that introduced folks to some of that basic terminology that you're going to kind of see as you continue through cryptography related problems. So you're starting out with your plain text, encrypting to ciphertext, and then decrypting back to plain text. So.
Okay, thank you, Jordan. The next question, Cake, is just a plain logic question. It relates tangentially to cryptography. It's also a yes or no question, so you can go ahead and guess if you don't want to bother reading through the question.
The answer is A.
I'm sorry?
The answer is A.
The important thing about this is how it relates to cryptography. Mostly, if you think about money, the analogy in this question is that money But in reality, when we're talking about cryptography, we're talking about data. But data is worth money. So if you think about this question in terms of how you need to protect your data, it stresses the importance of protecting your data at all times, not just when it's in transit, but also when it's at rest. Okay, practice does not make perfect. This is another terminology and sort of cryptography theory question. If you Google for theoretically perfect encryption method, you will get to the answer. And it's important to understand when you're looking at this question that this theoretically perfect encryption method is not one that we use in any of our data systems, which means that all of our crypto systems that we use are not even perfect in theory, much less in implementation. So they all have potential vulnerabilities that can be exploited.
It's funny, I actually think I read somewhere that like maybe there's like Swiss bankers who use this one-time pad encryption, but I feel like that's another level of security needed. So
Is that
still
how they,
incredibly impractical. Sorry.
is that how they make Swiss cheese?
Yeah. So one-time pads are just have a lot of difficulty with implementing them. You need a secure side channel in order to exchange your keys in the first place, and the discipline necessary to actually only use each key once is very difficult. And if you run out of keys, you can't send any more data. So that's another issue with them, and reasons that we don't use them in actuality. So always the same is introducing aspects of cryptanalysis, which is so when we talk about cryptography, there's all the parts where we're worried about crypto systems and how to encrypt data securely. Cryptanalysis is all about how we are attacking crypto systems. So cryptanalysis is all how we can analyze data that we can get from crypto systems and break it. One second. So in cryptanalysis, there are various types of attacks that we can do on a system. And if we Google for types of cryptanalysis attacks, we get a lovely page from Geeks for Geeks that talks about different types of cryptanalysis attacks. And if you read about them, this particular question is talking about a known plain text attack or known plain text analysis, and the answer is just known plain text. because we know a phrase of the plain text, that's why it's a known plain text attack. And it's actually a very widely used method and is a vulnerability in a lot of crypto systems if you use repetitive text over and over. It's why if you're interested in keeping your encryption methodology secure, you should not use like the same header on every message, because if they break one or have a way to find out what that header is, then they can do some known plain text analysis in the cryptanalysis against your system. And with that, we are done with the introduction section. I think we're going to take a break before we get into the next section.
Yes, that is right. So we'll take about a 5-minute break. So if you're working on any of the other challenges and you have a question, now is the time to speak up and we can help you. And then yeah, 5 or so minutes, then we'll start the next round of questions. But thank you, Karen, for getting us started.
You're welcome. And if you have any questions about the introduction section, please don't hesitate.
Philip says, I'm struggling more with the expected flag format than anything else. Okay. Max, you're on it. Awesome. Thank you. Nestor, I was trying to hack a communist bank in Latin America, but Kali tools seem to be out of date. I'm not going to answer that one.
That seems to be a personal issue.
Yeah. Oh, that's a good point, Philip. We will make a note of that.
Yeah, I believe some of these questions we may have forgotten to specify all lowercase or something like that.
Do you guys hear my dog snoring?
Nope.
All right, just making sure.
Yeah, no, I hear silence. Okay. It's 11:35 my time. So for the next 30 minutes or so, I'm gonna hand it over to Max, our second presenter, who will show you a couple more questions from our CTF. And again, please ask away in the chat if you're stuck at any point. We are here to help you out.
All right, moving right along to obfuscation. So, as you may know, cryptography has been a very important subject even before computers, especially in warfare. The origins of cryptography date back to codes and ciphers that mostly involve some form of obfuscation, which usually involves a natural written language with the letters and words mixed up, substituted for others, jumbled around. A great way to start this is with one of the most common or well-known ciphers, the Caesar cipher. So this first question, named after a famous tragic quote, which may or may not actually have been said. A historians recently found an old stash of ancient Roman scrolls which appear to have been used for military communications. If you don't know, back in the days of the Roman Empire, Julius Caesar was known for sending enciphered messages to and from his troops so that the enemy couldn't intercept them. And the cipher that he used is called the Caesar cipher. The Caesar cipher involves shifting the letters of an alphabet by a certain amount. So, give an example. Let's just go over to Decode, which is a great online tool for a lot of things. And let's see, what are we looking for? The Caesar cipher. The way the Caesar cipher works is, say we have an alphabet. For this is the English alphabet, A, B, C, D, X, Y, Z. And if we put in a message, we'll say hello. The way this will work is we go, if we want to encipher this message, hello, we go letter by letter. We start with the first letter, H, and we have to know the shift amount in order to encipher it. So we'll just say 1. We'll shift it by 1 for simplicity. And if we look at H in the alphabet, we're going to shift it down the alphabet. So the letter that's right after it is I. So H will be replaced with I. Should be simple enough. This is in decryption. Let me put this in encryption and we'll see if it actually works. And here we get an I in the first place. Next letter is an F. If we look at E, the original plain text, so to speak, the letter that comes right after E is F, which is in the ciphertext. So anyway, pretty simple cipher, but if you don't have a computer, it can be difficult to, first you have to identify it, then you have to figure out how to crack it, which takes creativity and it takes time and lots of thought. So going back to our challenge here, Real quick, looking at the format of this string of characters here, can anyone tell me what kind of attack this cipher text would be vulnerable to? It was something that Karen mentioned very recently in the last question, I believe. It's all right. Don't speak all at once. I'm talking about a known plain text attack. So in our case, this looks suspiciously like the format of our string crypt, except with the letters substituted. Here we've got 5 letters in the beginning, and then an open bracket and a closed bracket. So let's go look at our, let's copy this and let's go look at our Caesar cipher. I go into here and I look at F. So if F is the ciphertext, that means that something was shifted down the alphabet to get to F. So if we want to go the opposite direction, we got to look up the alphabet. So we'll start at F, and our expected output should be something like crypt. So if we go up from F, up to C, that's E, D, C. That's 3 shifts. Okay, maybe it's 3 shifts. Let's check the next one. U should decrypt to R. So we'll look at U, go up 1, 2, 3, and it's R. Okay, that's promising. Now let's use the decryptor and see what we get. And we get something that's formatted as a flag, but it's not in English. Now I wonder, yes, the answer should be expressed in English. So, I mean, it makes sense, right? The ancient Romans didn't speak English. Why should this ancient scroll be in English? So I'll let you figure out how to get the flag. Hint, hint. Google Tools, and that's basically the Caesar cipher. Any questions before I move on? Nope. All right. Next, we're going to move into a different kind of cipher, the transposition cipher. So transposition is different from what we just did, which is substitution. Substitution ciphers take letters of an alphabet and replace them with other letters. Transposition ciphers mix up the letters. So this challenge deals with a transposition cipher called the columnar transposition cipher, and it works a little something like this. I'm gonna try something, everyone. Let's see if it works out. Start a new screen share. Can you all see a blank canvas?
Yes.
Okay, cool. So let's say I want to encipher a bit of text. Handwriting. My space secret space letter. I want to encipher this message. The process goes like this. First, say our transposition cipher has 4 columns. I'm going to write the rows. Here, I'll make a little table. I'm going to write the rows. M, Y, space, S. That gets the end. I'll write the next row. E, C, R, E. Next row. T, space, L, E. Next row. T, T, E, R. My secret letter. So that makes a nice 4x4 um, uh, block, basically. So that's the first step to encoding. Let's go down here. The second step is to mix up the columns. So I'm just gonna go ahead and I'll switch these two columns to make it simple. So I'm gonna make this a little smaller. That will be space R L E, and then second of the change, YC space T, third M E T T, and a second fourth S E E R. So this is our new columnar cipher. So the second step is finished. The last step in creating the ciphertext is we just read the columns. So we start at the top left and we go down, and when we get to the bottom we switch to the second column, and so on. So that is space R L E Y C space T M E T T S E E R. And there's your ciphertext. So the things you need to know to decrypt this, of course, are the number of columns and the permutation of the columns. In this case, since we switched columns 1 and 3, the order is 3, 2, 1, 4. It will be 1, 2, 3, 4 if it wasn't switched. So knowing all that, now let's try to decrypt this string of text we found. Up here it says try deciphering. Let me switch back to, there we go. Try deciphering the following flag using columnar transposition with this permutation. 4, 2, 1. Okay. Now I don't expect you to do this all on paper like I did, so let's go over to decode. Why did I type decode in there? I'm stupid. Here we go. All right. So I've got the cipher in here. I'm going to keep spaces and punctuation like we did. We put spaces into the columns and mix them up on our own. And language is going to be English. The decryption key, I'll go ahead and copy into here from our answer. And looks like there's also a brute force option. Now with decode, of course, if you know the permutation key, you also know the number of columns because it's just how many numbers there are. So looks like we've got everything we need. Let's just decrypt it. And we get a flag in English. Sweet. So bonus points to those of you who are paying attention. Free flag. Okay. Oh, 11:50. Time flies. I'm going to run over to, I'm going to do Ruby off the rails, and that would probably bring us to 12 o'clock. This is another transposition cipher. Given the content of the description and the name of the challenge, can anyone guess what cipher I'm going to talk about now? You can throw it out there. Don't have to, you could be wrong. It's fine. Okay. Well, anyway, it's the rail fence cipher. The rail fence cipher is another opportunity to use the drawing tablet. Let me share. Let me show you how the rail fence cipher works. It's also a transposition cipher, so that means we're just mixing up text. Say I want to encrypt my secret message. There's two things we need to know. Three, depends on how complicated it is. The first thing you want to know is the number of rails. Let's just do 3 rails. It's that simple. And then second thing you need to know is if you're going to start on the top or bottom. We'll start at the top. And then the last is the shift amount, which we won't worry about just yet. But, okay. So to encrypt my secret message, we've got 3 rails. Now we're going to run this message across the rails in a zigzag pattern. So we need to start from the top. So M is going to, we'll put M right here. Might as well draw out the rails. 1, 2, 3. So M goes on the top rail. Next one, Y, goes on the second rail. Then we have a space, put on the third rail. Once we hit the bottom, head back up. S on the second, E on the first, and so on. So now that we have this zigzag pattern going on, we've written in a zigzag. Now we're going to read the rails, starting from the top and going down. So first we've got M, then E, T, S, then we go to the next rail, Y, S, C, E, M, S, A, E, and the bottom. I think I forgot a space in here actually, whatever. Space, R, E, G. Looks like abstract reasoning. Yep. It seems like a lot of these ciphers were created by people who were just bored and just were like, hey, what if I have this crazy idea and no one's going to be able to guess it? Which is kind of what I like about obfuscation. You can really let your creativity flow with it. So that's the general process. Say we want to decrypt this message that was broken apart by a train running across it. Go ahead and go to decode again, because It's a good site. And the cipher is called rail fence or zigzag. So like before, we're keeping punctuation in spaces. The alphabet doesn't really matter. Mixing up all the characters. Number of rows we've got is 3. We're going to start from the top left instead of the bottom. And the offset we mentioned before, it has to do with, maybe to make it more complicated, you start on the middle rail or you start on the third rail. That's what the offset is. But we've got no an offset this time. We'll decrypt it, and it writes out, it shows you the rails and the message. I don't know if any of you have ever put a penny on a trolley track, but it flattens it out. It's pretty cool. I've never done it before, but wish I could someday. Does this make sense to everyone? We're almost out of time, so I'll point you towards columns and rails. Given what I just talked about, you should be able to do that just fine. It'll be a bit more challenging. And I suggest you also look at the Veganare cipher. I don't know how to pronounce that, I'm sorry. It's a more advanced cipher. It's closer to a one-time pad, I feel, than just a simple key. And you can look at that in your own time. Veganare. Thanks, Jordan.
Like visionnaire. But like I said, I'm not French, so I'd still be butchering it.
I mean, I've heard people just say vinaigrette, and I'm like, no. I know I don't have it right either, but no.
Oh,
That's amazing. I'm going to start saying that, I think.
Vinaigrette.
I just remembered.
Vinaigrette, lemon vinaigrette.
Yeah.
I just remembered one more challenge I put in here that's unrelated to the others, somewhat. There's one challenge that substitutes all the letters randomly using a random alphabet. See if you can crack that one. It's a bit of that might be a little challenging, but any hint to figure out the permutations for column and transposition in columns and rails? Okay. Well, looks like there's no permutations mentioned, so maybe you can try that first. Column or transposition doesn't need to have permutations. I notice usually in CTFs when they don't mention crucial information, sometimes it's just using the default standard. Thanks, Nestor. Yeah, it was fun making these challenges.
It is noon our time. Thank you, Max, for awesomely showing us how to solve more challenges and using your pad there. I think that was a great idea for this. Just like we did a little while ago, we'll take a 5-minute break. If you have questions on other categories that we haven't hit, now is the time to ask away. Or if you want to take a quick bio break, that's fine too. So in 5 minutes, we'll have the next round of questions.
Is that totally random one supposed to be all lowercase or capitalized or?
It looks like it's all lowercase. There are spaces in between things that are used with the underscore. Or spaces are represented with underscore. There we go.
But all the capitals are supposed to be lowercase.
Yes. Oh, hang on. Sorry, I was looking at the wrong one. My bad, my
The
bad.
capitals stay capitals, the lowercase stay lowercase.
Yeah, my apologies. I was definitely looking at the wrong challenge flag.
Sorry about that.
Did that.
It happens. Okay. 12:05 our time. We'll do another 30 minutes. I'd like to introduce to you one of our team leads and also the person who created this idea of making a crypto CTF, Jordan.
Thank you, Irvin. Hi, everyone. Great to be here again. I'm going to let's see, walk through a couple of bits and bones category. So let's see, I find that approaching some cryptography problems are pretty fun when using Python. So I'll kind of go over a couple of these questions, and then I'm primarily going to use Python to help work through a couple of these. So we have on the page here, you know, your link and guide to Replit. We didn't assume that people have Python installed on their machines, but we're going to be using Python 3. And there's also a link here to some of the collections that are particularly useful when solving cryptography problems with Python. So primary focus is Pwn tools and PyCryptodome, but you can still solve some of these things without even using those collections. So yeah, we'll get started. So the first, I thought this category was particularly important because, you know, like Irvin said at the beginning, the idea of this cryptography introduction is to sort of not focus so much on the math concepts, which are admitted, like obviously very important, but there's a lot of logic as well that comes in. So I thought it would be cool to, you know, sort of tie in some of the logic truth tables and, you know, understanding how those work with bit operations, and, you know, under the hood, we're always just working with bits and bytes, right? And so we have these great tools, we have programming language, we have security tools that abstract all of these things away, but under the hood, it does just come down to the zeros and ones. And so I added in a couple of these challenges. We begin with the logical and operator. And if you're not familiar with truth tables, definitely check out this Wikipedia link. It's pretty prevalent in like Boolean arithmetic, which we see quite a bit with computers as well. So, and if you are not a math person, that's totally okay. These are math concepts, but it's a little bit different. It's not something like algebra or calculus, you know, it's sort of its own set of math and like discrete math or finite math. So for people who are not math people, this could be your kind of math. So anyway, moving into this, bitwise AND operator compares two equal length binary representations. Basically, if the two bits are the same, or if the two bits are different, or excuse me, if both bits in the compared position are 1, it outputs 1. So basically, if both bits are 1, that's the only time we output 1. And okay, getting sidetracked by some chat. Okay, so what we're going to do is basically just open up a terminal. I'm going to interact with our Python 3 shell. And so what we can see here is most languages use this AND operator. So it's pretty simple to begin with this. We can type in, we're going to perform bitwise AND on 167 and 197. So these are just right now integer representations. So we can pretty much just type in at the line this. So the interesting thing is when we are working with bit operations, you know, we're not always presented the data in binary. And so sometimes we're given decimal integers, sometimes we're given hexadecimal representation. So the idea is that we always want to kind of convert from whatever representation we are currently in to something that can be used, or basically transform it to binary representation. With Python, some of these things are abstracted away, so we don't necessarily have to go all the way down to binary. As you can see here, we get basically the output. What we can do though is get a binary representation of 167. We can get a binary representation of 197. And then basically what we can do is bit by bit compare these values, and then from there we can come up with the final representation. So we'll go back to just 167 and 197. So we have this value, but we need to convert to hexadecimal. So what we have here is we can basically, I will do it element by element, but I won't do it all. Like I said, it's pretty straightforward once you kind of see the different functions that Python provides. So we'll have hexadecimal, so we can see how that value is represented, and we can do 197 as well. And then what you can start doing is nesting a few of these things. So we can take something like this, 167, there we go, and 197. Et voila. So we get a hexadecimal representation of 85. So that's bitwise and, just easy introduction, and a flag for you if you've been paying attention. So what I will do is continue on. So let's see, we've got flip a bit, which is, all of these are going to be bitwise operators within bits and bones, or challenges that deal with bitwise operations. So bitwise not is just a negator. It's pretty straightforward. What I would recommend for this challenge is maybe doing it by hand. For some of these things, I would encourage you to practice doing by hand. I know some of these challenges take less time to do it by hand. So what we can do is basically just see what 65537 looks like in binary. Right, yeah, Python is pretty great for some of these quick cryptography, just like need to rail out some scripts pretty quick. It's been quite a bit of fun. So as we can see here with the truth table, basically, like I said, you negate. So if the bit that's coming in is a 0, we flip it to 1. And so we see our binary representation here. So what we can do is basically just write out the flipped bits. And with this challenge, we don't want to drop any bits. There is the, representation, or there's that idea of like, if you have zeros at the far left side has zeros, those are dropped sometimes, but in this challenge, we keep all of them. Okay, moving on. Okay, exclusive OR. So this has admittedly become one of the most common operations that I've seen in cryptography. I joke with a friend that cryptography is basically XOR and large primes. So this is arguably, I think, one of the most important concepts. So exclusive OR, again, another bitwise operation, returns 0 if the bits are the same and 1 otherwise. So I like to think of this like, I don't know if there's an Olive Garden around you guys, but they have that like soup salad deal, and you can either get soup or salad, but you can't get both. And why would you not get either one if that's the deal you're going for? So it's the same kind of thing. You have to have one or the other, but not both and not neither. So so Python has, within most programming languages, XOR is denoted with the caret. In textbooks, it's the circle with the cross through it. And what we can do is, let's see, perform. It's kind of similar to the previous operators where you can kind of, at this point, Python will still abstract away some of these details of, moving it down to binary or backup. And so we can do a pretty straightforward XOR operation just from the shell. And similarly, what we want to do is wrap this in the hex method to reach the desired output representation. Et voila. So pretty swift, pretty quick. That's the fun part of this. And I'm showing these in Python now, but Python is not the only language. I wouldn't say that this is like the best language to approach some of these cryptography problems with. I think it's specific to the problem. So by no means am I saying this is like the best way to do it, but as far as I found as a student, it's been pretty fun working through some of these things with Python. So yeah, okay, so I'll work through one more, and then from there, I think you should have enough to be able to complete the rest of the challenges below. So let me pull up my little. Okay, so with this one, we want to encrypt the string electric feel with the integer 7. The flag is a ciphertext as a 12-character string. So there's a couple of ways to approach this problem. I personally have been using what are called list comprehensions pretty regularly with these problems, just because it's kind of compact and quick to find, quick to come up with a solution. But what I will do is work through it a little bit more slowly. So we can start out, because I'm still in my Python shell. So we want to set the key to the integer 7. And what we're going to do is basically perform some operations on this electric field string and put it into a new list and smush it all together to make the new string. So I'm going to call new string as such and create a little empty list. And so what we'll do is, the idea when we have strings is that we need to convert each character of the string to an integer representation of that character. So in Python, they have a neat function called ord, and basically it just spits out the ordinal representation and Unicode of that character. So it's great. And it also, there's another function that works in conjunction with that, chr, and basically you can switch back and forth from character and ordinal representations using those two functions, which you will see quite a bit. If you have any interest in cryptography and want to continue on some of the from peeling away some of the abstraction, this is definitely something you will continue to come across. So, so the idea is to isolate each character, convert it to an integer representation. We'll perform the bitwise operation and then basically convert it back to a string. So we'll start with our for loop for x in electric field. I need to tab over. So ord value is going to equal ord of x. And x for x in electric field, basically what that does is we'll just cycle through each letter of this string. So continue with that. I'm not going to print a bunch of, in my, at home, it might be wise to go on ahead and do some sort of debugging and say, I'm going to print out this value and just make sure that everything's coming through. But I don't think that's totally necessary. So what we're going to do is, now that we have each character isolated, or each character at a time isolated, and its ord value, what we need to do is XOR it with the key. So we're going to have XOR with key equals, we're going to have our ord value, and then remember the symbol used to denote XOR in Python is the caret. So we're going to XOR with the key. And then we will continue down, and then our return character is going to be we want to convert back to character, and then XOR with key. And then what we need to do is, so like I said, we're cycling through one character at a time. So what we're going to do is shove those characters back into the new string list that we created at the top. So new string, append, return, character. And then from here, we want to print the new string. Oh, where do we go? Line 6. I actually have this right here. So what we can do is nano XOR.py. Oh, actually, we need to exit out of this. Nano XOR.py.
Jordan, I think you forgot a close parenthesis on your return.
Yeah, that's okay. It's probably just quicker to do it this way. Because then I'd have to cycle back up and type everything out again. So.
Right, yeah.
Oh, here we go. Oh, right, because I forgot to add in key at the top. Okay, so this is what I was trying to avoid before, is the breakdown of each character. So we'll just move down to the string. So basically what we are returned, or what is returned, is each value converted to its ordinal representation, XORed with 7, and then converted back to its character representation. And then what you can do here is some other Python code to join this back together and make it a nice, easy string, but that's not relevant right now. So so that's kind of long way, or not long way, it's a very readable way to convert this or to encrypt this. But what I will also show for folks who are interested in list comprehension, because I think it's quite a bit. Oh, we need to do key first. Key equals 7. It's pretty swift, but less readable. So, there always is that balance. Okay, for X and. Okay, how does that look? Yep, parentheses are together. So, et voila. So basically, a list comprehension is a smushed for loop. So we have for X and electric field, do all these things, and then return it as a list. And then we can also do a join. Et voila. So yeah, I think as of right now, that should definitely set you up for future challenges. Let's see, we're basically kind of continuing through, and then some of these are combinations of operators. So, oh, there we go. Cool. All right, any questions? I know I just went through quite a bit of Python stuff, so we just dove in.
Cool. Well,
Sweet.
thank you, Jordan. I think the last 40 minutes or so we'll open up for questions. So if you want us to demonstrate a specific question, now would be the time. Or if you're stuck on a question, please ask away, but we will be here watching the chat and listening in if you need any help.
I guess I'll mention a shout out to Sir Lin for being top of the scoreboard this whole this whole meeting.
Nice, nice. The site will be on for a while. As like I said, this is our first presentation of this system, so I know we already have some notes on the back end to make some fixes. So it is going to go down at some point and then be brought back up. I will announce that on Twitter. So if you want to know when the next iteration is up, that's where I will announce it.
What's your Twitter handle? InfoSec Irvin. Nice.
Yeah, no problem. Thank you, Jordan.
Hey, Irvin, thank you for running this today. I see you got a lot of people. Thank you guys for putting this together.
Thank you
So
for letting us present today.
it's Sterling winning.
I think we're actually looking at, yeah.
Killing it.
Sterling is a dangerous person. He's always winning all this contest. He wins all this contest all the time. Yeah.
Turns our HackMiami ringer.
We need to take you to DEFCON, Sterling.
We have when Sterling does our CTF, we have to give him a deficit of 100 points or two.
Handicap.
We might do that for next time.
Yeah, now that we know.
We'll have Sterling only questions.
You should have this, but you can do this again in the during the festival. Do it if you want.
Sounds good to us.
I'm here for that.
Great.
Yeah, I mean, it'll help people can finish it all in 2 hours, give them another chance.
So you guys are doing your festival next week, or
We are. Yes.
nice in person?
Yeah, I'll be
Yeah.
there.
Yeah, in person.
Yeah.
Where are you guys gonna be at?
Maker Nexus.
Maker Nexus?
Yeah,
Yeah.
it's in what is it, Santa Clara, right?
Yeah, Santa Clara.
Nice.
Yeah, Respeto. California beat Florida. They're gonna do it first.
It's okay. We're gonna do a test run.
You guys announced it, right? That must have been there
Oh,
was
yes.
more people. Yeah.
Yeah,
Okay.
you announced it at the beginning.
Excellent.
Well, we announced the Winter Hacker Fest. I didn't understand about the Pacific Hacker.
Oh.
Yeah. After you said it, Respeto, I said we're also doing it on the 11th.
Let me see. Do you have a link
There
to
is a meeting today for Pacific Hackers. We have actually a 0 day. Somebody's going to present about a 0 day today in Socas' service, which is Kevin.
Yeah, I saw that. What time is it again?
2 o'clock.
2 p.m. Pacific.
Or
That
like I
would
said,
technically be our first CVE, by the way. The first CVE ever gotten by Pacific Hackers.
Awesome.
Nice.
so we have 30 more minutes to see who wins our crypto CTF. Again, if you're stuck at any place, please ask away. Because otherwise, we're just going to be chatting the rest of the chatting the 30 minutes. So yeah, feel free to jump in and ask us questions.
Hey, Rod, can you share the Pacific Hackers meetup link?
Yeah, I'll do it right now. Hold on. Michael was asking me to change it to 11 to 5. Do you guys want to do that?
I thought that was the time we were going to do it.
No, I was doing 2 to 5. But I guess you're gonna have to send me as a presenter.
Oh, yeah. Give me 1 second. There you are. Make presenter.
Okay, thank you. Here, or window rather, Chrome tab. There we go. You guys can see this?
Yep.
Okay, so here's El Respondo. Are you looking at this?
Yeah, yeah, I'm seeing
Okay,
it.
so this is today.
On your end.
This is today. I haven't updated Kevin. Julie can come, but Kevin is gonna do his thing, and then we're gonna have there the Winter Hacker Festival in see it's 2 to 5. So I mean, if you guys want to change it, I'll be there for this. So I can put it at 11, not a problem. If you guys are gonna show up, we order pizza or whatever.
Sounds good to me.
Yeah.
Probably show up
Okay.
if it were earlier.
Okay, so I'll change it in a minute. Actually, let's see if I can change it now. Yep. So we'll change it here to 11 a.m. On, although it's not. There it is. Oh wait, I gotta. I'm gonna have to edit it again. All right. Done.
Cool.
Yep. I shipped the stuff yesterday, Urban, so it should be there on Friday.
Which
Awesome.
meeting platform was this for?
The one?
The CVE. Let me just look it up.
It's WebEx Respondo.
Oh, it's for WebEx?
Mm-hmm.
Nice.
Yeah. Are we going to put this online too, or that's a good question because I didn't send the GoPro, but I can take it with me.
Gonna be a little. I don't know. Because we're all gonna be doing different things.
Right.
It's just gonna be a live feed of people clicking away on keyboards or
Doing
trying
stuff,
to break,
right?
trying to break open locks.
We can, however, put it on Discord. We can put it on Discord, and people can actually see the feed or play the CTF if they want it.
They'll hear everybody's grumbling, solving through questions. Why did that work?
Right.
Where's the answer?
We're gonna have to figure that out when we start doing hybrid meetings.
I think for the hybrid meetings, that's not a problem. For something like this HackerFest at either Miami or West Coast, it's gonna be the same thing if everybody's just clicking away.
Hey, Respecto, what are you thinking of doing?
I was thinking of broadcasting you on the DJ booth.
Oh, nobody
Yeah, right.
mentioned
I'm not.
okay, okay.
Yeah, and then we have DJ. We have DJ Rod Soto, you know, and
Hey, we have
It's
DJ
DJ
Marco.
percent 27.
DJ Percent 27 on the ones and twos, you know, and
Going to get config to code GJ or something.
Oh yeah, we can bring Dan. Dan is an ultra veteran.
he's at Ultra.
Yeah,
Ultra.
Dan has been an ultra.
Heard
Yeah,
of. Nice.
And
Yeah.
also has DJ DEFCON, hasn't he?
yeah. He's done DEFCON and ultra. Dan is a pro, dude.
Jeez. Damn. Does he wear the marshmallow helmet too?
No, no, I don't think he will appreciate that either.
Or the mouse helmet.
How about making him a Corona Jack helmet?
I can make him a helmet.
Yeah, but we okay, so maybe you know what? I'm gonna take my GoPro just in case so we can test for the future meetings. And then maybe some portions of the meeting will be actually broadcasted.
Okay.
And we'll figure it out. We'll figure it out.
Yeah, I'll come up with something and send it your way, Rod.
Do what?
I'll come up with something.
Okay.
With
Well,
our-
our responder's going to have like a, influencer type of setup. And
with our boost level on the server, you could broadcast. You could broadcast at 1080p at 60 frames per second
wow.
on live. So
Do we really have to get that fancy though? Well, as long as we're not doing something on YouTube where it detects the music and it decides to shut off the stream.
Oh,
oh yeah, if you're doing it on just if you're just turn on OBS and then just broadcast your camera over to or whatever.
Or even the
Or-
WebEx or whatever. But,
Yeah.
well, WebEx may not be the most musically inclined.
No, I think streaming on just straight on Discord, that stuff would be fine. And hey, we all
Right.
get to see DJ Rod Soto.
yeah.
You don't even, I don't even know after COVID where all my conference recording equipment is.
Oh, that's true. The Serling was the original recorder of the first two conferences too. You did the second two or not? I don't think you did the
Did
second.
the first Pacific Hackers. I've done
You
more
did the first
HackMiami than Pacific Hackers. So
Right.
I don't have an excuse to fly out there now. I need an excuse to justify having a security search at the moment. It's fun. But that's the way employment goes.
Right.
I have to make a nice Pelican case for the mixer and all this stuff.
You truly
Yeah.
gonna put DJs that day?
No.
Oh,
Joking.
okay.
Just
I'm like,
just
how we're gonna do that? No, that we done this before. I know.
I was gonna do just a camera and a microphone or a
Mhm.
second microphone for the background for the speaker at the table. If someone wants to do a fire talk, we could probably broadcast that, But going to, there's gonna be a lockpick village table. There's gonna be you messing around with the drone and no quarter, So be a bunch of other things. We could probably do a couple, but I don't have that many types of cameras or remote cameras to like.
Well, when we had the drone flying, and people trying to take it down, that would be like a good thing to film. I'm taking a small drone to California. It's a pocket drone, but there is an exploit for it. So if you have the right tool, you can actually land it and put it and take it up. make it take off.
Is it like one of these little guys or like these
Yeah, they're
little
nano drones.
drones?
We can't fly over than that. Then we're gonna have to ask for permission. You know that you're supposed to have that tool. What's it called? Before you fly. And if you're close of any airport stuff, you can even fly that.
Well, I know some of the drone, the like the Mavericks and stuff,
Mhm.
like they have like built-in GPS sensors, and they'll say, "Oh, wait, you can't go over a certain altitude here, and you can't go any further to closer to this radius of like we were trying to fly a drone. We're flying the drone around the office over in downtown Fort Lauderdale. It was in the Maverick was like, oh, can't go over there. It has a big red zone because of the the prison right there
Right.
or the courthouse as well. You know.
Hmm. You can, however, you could have gone to the top of your building and fly it from there, which then would have gotten you into another sort of trouble.
No, could have gone to. We flew the drone from there, and just went up and just looked around. But I don't
Right.
think that
What I
there.
wanted to do, to be honest, I got the drone that is fixed wing, and I wanted to do what this guy did in Hawaii. He flew it from one island to the other using a 5G modem, and I wanted to fly it from Homestead to Miramar, but it's impossible. There's so many no-fly zones. Forget about it.
Yeah, I don't even think you could go through. You can't even go through the turnpike or fly over around unless you're like
Yeah.
wait there no because you have MIA and then you have
Right. Homestead
um,
Air Force Base. You have all kinds of executive airports. You can fly anywhere near that.
mhm.
The park you almost held the event at was just at the edge of the approach to one of the airports for drone prohibitions.
Hmm.
So what type of radio do we need to take down one of these little guys? You just need
Is that Wi-Fi?
no, it's just one of these little RFs.
Use a I'm assuming we can use a what's it called, man?
Hacker.
Hacker F. We can use a Hacker F and record the transmission and try
Mhm.
to replay it or jam it. But I don't think Hacker F has jamming capabilities.
If you have the no, if you have the Havoc and the Portapack, you could
I
probably.
have that. I have that.
I have the Hack RF. I just don't have the Portapack.
I had the border pack with the Havoc. Yeah.
Yeah, so you can do that. Is that how you did the
I can
CTF?
take it. Which
Is
one?
that how you did the CTF over in Las Vegas?
No, that one was a telnet.
Oh, okay.
I telnetted and I read the manual of the drone and I just put the shut down. So I shut it down in the air and the thing went down.
Ah, it was one of those. I thought it was
Well, you have 45 seconds to take it down.
but the drone was in the but the drone was connected to Wi-Fi to so that you could
The
actually.
drone was connected to a terminal and the drone had a chain so you wouldn't fly it against the wall or against the roof.
Yeah.
They give you 45 seconds. In 45 seconds, you have to take the drone down.
Mm.
So if you don't know the
No.
commands, if you don't know the commands, you will be typing stuff and nothing will happen.
Oh, we should probably show how to. Oh, here's the Wi-Fi. Here's the Hack RF. The remote control is at
I can take my Havoc. I have the Hacker F with the Havoc and see if we can. You should take that drone, man.
Yeah, I'm gonna take this drone
I'm gonna
and
take a DJI Nano. The DJI Nano is pretty good and it flies very well internally, or inside, indoors, and it can be taken down. It's over Wi-Fi.
Oh wow. If it's over
Yeah.
Wi-Fi, that's
Yeah, I
cool.
also have a Parrot that I was able to fly over 1.5 miles on Wi-Fi.
Yeah, but this is like only $30. This is like a $30 drone. It's not
Yeah.
like
Can you even keep it steady?
this one. This one has auto. This one has a good hover. It has a good hover where you could just, if you tether it, with a loose tether, it'll stay in a certain area, you know,
Mhm.
so it won't fly against anything. And it has like the batteries are interchangeable, and they're like like at least 5, 6, 10-minute batteries.
No, I have a lot of batteries, so we can have it flying a long time.
Oh yeah. Let's see if I can pick up another one.
Yeah.
And
Well,
about
mine drones are Wi-Fi, so that's the tool that they're gonna have to use. They're gonna have to use Wi-Fi. They can jam it. If you jam it, it will use return to home. Or you can actually telnet. Well, the tool will telnet into it, and you can sort of execute commands.
what I want to get into is this. I haven't been able to mess around with this Kerberos SDR since I won it, and this has been on my shelf, and I've been like dying to like start buying some antennas for this sucker and mess around with
Oh
triangle.
wow! You see
With
that you can use that to jam that little drone. You just need the antennas and the software.
Yeah, you just need the antennas, the software, but you need to. But this you can use to triangulate other radio frequency radios
Right, they're
and
not sold anymore.
locate it and locate the radio transmissions.
Mhm.
It's pretty. This guy's really dope. I really want to play with this. Just haven't had any time right now. So, any new guys in the channel in the meeting today? If you're new and you want to say hi, you can feel free to unmute yourself and give a quick shout out. Say how you doing.
Or if you're an introvert, put it in the chat.
Oh, that's no problem if you guys want to stay shy.
No time for talking when there's challenges to solve.
That too. That too. And I'm going to be calling it in 6 minutes. So yeah, if you want to race to the top, you got 6 minutes to do so.
Get those points in, everyone. Purple Thunder's coming up in the rankings.
Everyone's gonna start putting in all their flags. They've just been holding them back.
They've been holding them the whole time, and I'm in trouble.
Flag hoarding.
Yeah.
I mean, there's a
How
lot
do
of
you guys
little
feel about? How do you feel about that strategy in CTF's flag hoarding?
Well, it depends.
It could go
Sometimes it
bad.
helps, sometimes it doesn't.
It depends. Sometimes it could go bad too if you don't have, if you mistype that flag, then you're trying to resolve that problem again to try to fix the flag,
Right.
and you don't have time.
I need to start playing different CTFs because chances are I'm so used to rods, I'd lose at anybody else's.
Yeah, that's why I constantly promote CTF time and tell the participants of our competitions program to play as many CTFs as they want. I don't
Yeah.
care about them winning. It's just getting them exposed to various CTFs so they see different people and how they make various games.
Right. That's
So-
that's the way to go.
So you
can
guys
also-
designed this platform here?
Yes, we built it from the ground up,
Nice.
and
Well,
it's
hopefully you're, because hopefully you're at least logging everyone's bad answers so you have an idea how people got things wrong.
I believe we are. The backend team has been watching everything.
I think you should move the questions section to the center and move the tools, swap the two panels.
So the reason why it's like that is the end goal is really in the middle or most of the screen to be taken up by a virtual machine. Because a lot of the students that we serve have nothing but a Chromebook and can't do anything on them. So we provide them with a virtual machine and through the browser that they can do everything. And we're actually in process of deploying that part. So the way the games would work from then on would be after you create a account and get into the game, you would be presented with a complete desktop and then the questions on the side.
Have you seen I think that there's something similar to that with Home College has something similar to that as well.
I'm not familiar.
Yeah. Let me see if I can find the link. Or they provide you a terminal into the challenge where the challenge questions are.
Yeah, it'd be something similar to that. And actually, as we were discussing while doing this, we're thinking of this setup of making like iframes where when you click the button, instead of taking it to a new tab, it opens up that that thing you clicked on there. So you're not going in and out of different tabs. Because again, our main focus are those underprivileged students who all they have is a school issued Chromebook.
Yeah. No, it's a great idea.
Oh, there's the Metasploit CTF also going on this weekend, right?
Yes,
I think there's a team playing.
Advent of Cyber for Try Hacking is happening. KringoCon should be happening soon.
I think there's over the wires going on right now as well.
Down to our last minute. I have 12:55. So who won?
Is it even a contest?
Cool. Well, thank you guys for playing our brand new CTF. If you have
Unregistered Hypercamp 2, I was rooting for you.
I was trying, but there's no catching up to Certlin. Trust me, I'm used to taking second to him, so it was fun, guys.
I'm telling you, it's 200-point deficit next time, Sterling. 200-point deficit. Gonna be digging you out of a hole. You have to dig out of a hole first.
I have posted it on Twitter, so now Serlin has more things to brag about.
I don't have that nickname on. I don't have that nickname on Twitter.
Oh, well, there you go. I tag HackMiami. Cool. Thank you. Thank you, Rob, for letting us present this.
Of course. Actually, yeah, thank you very much. Maybe we'll run it again, and you should, this is something that you guys want to develop on. We already have like the Bluetooth CTF, the no quarter. We don't have a Wi-Fi, for example. We can always come up with contents and then run them from time to time so you guys can test them.
Cool. That'd be awesome. Yeah, we're definitely planning on continuing to build this one out.
Great. Thank you very much. And I'll see you guys in 1 hour.
Yes.
Right on.
One of the fun things was that I wanted to mess around was these ESP32s. This one has a camera built into it and could run a web server as well.
Huh.
So that you could load. So you load it up, and then I was thinking of saying, "Oh, okay, connect to this and see what the camera's pointing at, and try to decode that." Yes, but you would have to hack into the Wi-Fi for this one. So it's they're fun little tools for if you're in a certain location. If you're doing meetings at an event, there's at a location.
What is that? Is that what kind of? I'll look at it. If you have a link, maybe I can take one to California.
You could just drive by my house and pick it up.
Okay. Let's see if I had time. But yeah.
Yeah, this is just the ESP32 dash cam.
Uh-huh. Oh, wow.
Yeah. I'm going to stop the recording now.
All right.
All right.